To start with the panel discussions, and we have the first one about cost-effective asset management with digital technologies. And I want to welcome all the panelists and the moderators to go to the podium. And you will see that there have been activities developed, and we are going to use for these panel discussions pretty quick way to try to showcase what has been done so far in the cluster related with the work. So I invite Marco Borinato to the podium, and also all panelists involved in this first session. And in the meanwhile, so that you, not only in presence, but also those in the room, can see the activities of the cluster related with this panel, I introduce you a small video with Marco relating all the different activities that have been done so far. Here it goes.
Hello, I'm Marco Borinato from Hitachi. I am a data analyst, and within IAM4Rail, I am a Cluster B leader and Work Package 3 and 4 leader. So Cluster B focuses on the collection of operational and traffic data from the railway environment in order to provide this information to the railway operator. The implementation of a YAMS platform allowed the development of analytics to support the operator in the maintenance process and optimize the maintenance procedure on the line. Additionally, the focus of Cluster B is to support the TMS operator in the optimal rerouting of traffic in response to anomalies or malfunctioning on the line. In the past period, Cluster B has focused on the definition of the site location for the two demonstrators and the planification of the installation procedure to be implemented. Cluster B will perform two demonstrators in the Italian North Line and in the Spanish railway environment, where we will collect data from the traffic and the signaling system. In the past period, we have finalized the installation plan and started the development of the monitoring solution in order to acquire the operational data directly from the field. The data collected and stored in the two YAMS platform is going to be used and studied in order to develop data analytics and machine learning algorithm to support the railway operator in the procedure and to provide feedback to the TMS for the optimization of the traffic. Hello, everybody. Can you hear me all right? So, as you've seen in the video, my name is Marco Borinato. I am involved in IAM4Rail as a Cluster B leader and also as Work Package 3 and Work Package 4 leader. I will be the moderator of today's panel on cost-effective asset management and digital technologies. Before starting with the presentation, I will give the floor to the different panelists to present themselves, so we can start maybe from Luca and work our way to the table.
Hi, my name is Luca Oneta. I'm full professor at the University of Genoa in artificial intelligence.
Hello, my name is Temide Andreva-Moschen. I'm a senior advisor rolling stock at ÖBB in Austria.
Good morning, I'm Torben Holbert from the European Union Agency for Railways. Happy to be here.
Hello everyone, my name is Daniela Pietranera from Hitachi Rail Italy, mainly involved in development of integration automation technologies for the Railway Control Center.
Hello, everybody. My name is Jerzy Baranowski. I am from AGH University of Krakow. I'm a professor there, and my work is on data analytics and automatic control.
Okay. So, before starting with the discussion, I would like to introduce you to Cluster B. We have seen the video before, but basically Cluster B is focused on the development and implementation of IAMS applications on intelligent asset management system application in the railway environment. Cluster B is composed by two work packages, Work Package 3 and Work Package 4. And basically, the goal of Work Package 3, which officially will end at the end of November, so in a few days, was to develop the system architecture, the KPIs, and the requirements for the implementation of the two IAMS application, and provide this information to Work Package 4 so that during the course of the next 2 years, Work Package 4 will work on the actual implementation of the analytics and the link with FP1 on the TMS optimization. All of these under the umbrella, of course, of Work Package 2 for system vision, architecture, and validation. In the past period, as we have seen from the video and other activities that have followed, Cluster B in general has focused on the definition of the architecture and requirements, the planification of the installation on 2 sites in Italy and in Spain to collect data from different signaling railway devices. The development then of the different data collection systems, such as a non-intrusive data collection system from the TMS and the interlocking, the sensorization of different devices on the line, such as point machine, switch and crossing, and level crossings, and the development of an obstacle detection system that uses LiDAR and radar technologies together to support the operator in identifying the obstacle on the line. Finally, with the start of Work Package 4 in September, we started with the development of the actual IAMS application, the design of the different analytics functionalities that the 2 use cases will implement and showcase in the final demonstrator, and an early collection of data and visualization and the start of actually the data analytics part, for which we will see also a small demo during the lunch break. So, how does these link with the topic of today, so asset management and the digitalization of the railway environment? IAMS, so Intelligent Asset Management System, is a key enabler of the digital transformation in the railway. And the goal of today is to talk with the panelists that are here in order to understand what are the main topics and the main point of focus to actually bring forward this digitalization in the railway world. We will touch topics such as data availability, the requirements for collecting data, the centralization of data, and the use of diagnostic information in the railway environment. And we will work our way through the development of prescriptive and predictive analytics to support the maintainer, and the, let's say, use of all of this information to support the maintainer and the operator, providing a decision support system that is based on the data that we collect. So this concludes my introduction. So I guess we can start with the question. And I would like to start from the fundamentals. So my question is for you, Torben. What are the data requirements to actually enable and optimize asset management?
Okay, thank you very much. And again, also thanks for inviting me. I think this project is very important, and I think also this panel is very important in terms of dealing with cost effectiveness, cost efficiency, in order to strengthen the railway performance in Europe, and I think that's a key part of both in terms of strengthening the competitiveness of railways, but also in terms of facilitating the decarbonisation. In terms of cost-effective asset management, it's also a topic I think that is important to me personally, also as an economist. I think, what do we get out of the system? How do we consider railway activities as production activities? So I think that all that is important, and it's also put forward in the objective behind the IAM4Rail project in terms of several objectives like reduction of maintenance cost of 10% was mentioned, or reduction in in-service failures of up to 25%. All of those are elements that can contribute to strengthening the performance, the economic performance, and overall performance of the railway system. In terms of, I'll go a little bit one step back. I don't know how much time I have. I don't want to go too far, but I will keep an eye on time. But we have, of course, asset management as a key element involving, aligned with the provisions in the ISO 55000 standard as coordinated activity on an organization to realize value from assets. And that's really important, because then we need to start getting data on what is happening inside the railway system, inside the railway operations. And then we can look at ways in which to optimize. And all of that we can only optimize asset management if we have data. So that's a starting point. That is then linked to elements like RAMs, or to life cycle cost elements, and all of those elements, RAMs or life cycle cost processes, requires data. You would need data on on the assets, so asset knowledge, an inventory, the condition, the capacity, the criticality, and the cost, in order to feed the application of RAMs or LCC or other similar elements. All of that can, of course, also be facilitated further in terms of role of digitalization, and I think, apart from also looking at data requirements, you also have to look at how are those data going to be used, what are the analysis, how are they going to be used in decision making, what is the quality of the data, and how are they going globally to lead to action. So it's about data requirements, data availability, but it's also about all the other elements, how are data going to be used. Thank you.
You have mentioned data availability as one of the main, let's say, obstacles if data is not available. What are maybe the other obstacles and challenges for obtaining this data?
I think there are a number, and that I think also justifies the work that is being undertaken in IAM4Rail. I mentioned data quality. If the right data, or if data cannot be trusted, then you can't take any actions on those data. So data quality is a key one. I think another one is data silos. And that, in terms of leading to an integrated asset management framework, I think is one of the important obstacles to address, to alleviate the data silos. I think is really important to facilitate an integrated view of the railway system. There are others, but I don't think I have the time to go use outdated technology platforms. But also, I think important to highlight, in order to make improvements, it's also important to know where we are, what is the as-is situation. So you need to measure where you are today, and then you can then start defining possible ways in which you can improve the overall performance of the railway operation. Thanks.
Thank you, Torben. Torben has mentioned the availability of data and diagnostic information, so I think that this links very well with one of the projects that are in the system pillar, so HERD, or what maybe now it's better to call it Task 5. So my question is for you, Emilia. Can you talk a little bit about HERD and what is the Task 5?
Yeah, thank you very much. HERD is the abbreviation of Harmonized European Railway Diagnostics. And it is a very young project. It's a very young initiative in the system pillar, and we're happy that since 1st of October we became Task 5, and so we are a strategic area in the system pillar. What is the purpose of HERD? The main purpose of HERD is to strongly contribute for the railway system and the railway transport to become competitive. And how it should happen, and I fully agree with you, is using and utilizing the available data in the best way. And we have identified that harmonizing the interfaces will allow us to much better utilize the available data and also to generate new data. So therefore, we have identified the strong demand of generating the so-called harmonized diagnostic data interface. And this is what we are working now on. But maybe there will be a chance later on to explain much more about the HDDI. So why diagnostics? I think it is not necessary to explain it, David. You had made it in a perfect way, so everybody of us knows why diagnostics are needed. So for that, we have decided to focus on this kind of data, which is related not only on rolling stock, but also on the tracks, so all assets which are somehow involved and implemented in the railroad transport system. So, and our ambition is to create an architecture which is a flexible combination of wayside sensors and also of onboard localization systems, and then to allow combining this information to support and to support for better asset management. So in our targets, we have identified, in our work, we have identified specific areas which are relevant for the definition of the HDDI. We called them use cases, and I can now identify that many of our use cases are strongly related with your use cases, and it shows us that this collaboration between HERD, Harmonized European Railway Diagnostics, as Task 5 in the system pillar, and the innovation pillar, specifically with the flagship 3, is part of our purpose. So we will focus our work in the next time on this collaboration, and we will find new ways to achieve our goals, and we want to support us, and we will need your support.
Thank you, Emilia. I guess you've touched on some of the topics that HERD has already, let's say, focused on. So what are the next steps for HERD, and what are the outcomes of this first part?
Mm-hmm. As I have already mentioned, we are a pretty young project. We have started 1 year ago. And in this 1 year, from my point of view, we have achieved a lot, thanks to all the team I have here, you, Marco, and you, Jörg, too, as a member of the HERD team. And thanks to this very good collaboration in the team and the support from other areas, too, we have identified the needed input for this HDDI, for the Harmonized Diagnostic Data Interface. And we have performed 32 interviews in total for both use cases with data user and also data provider, which was a lot, believe me. We have done it in the summertime. You can imagine it was not so easy. But that has allowed us to understand what is needed for this Harmonized Diagnostic Data Interface and how we should start with the work, on which level we should start, because there are different levels, what can be harmonized and how we can work on that. We also have created and implemented a new process for identifying new use cases for harmonization, and I'm very happy that there are also new applications for that. What should happen in the next time? In the next period, starting from now, we will specify the HDDI for one use case at least. That will be the use case related to the wheels and collecting the diagnostic data about the wheels. And we will also proceed on the definition of the HDDI for the second use case related to the track quality. And we are very interested in exchanging with you, because the topic of data quality was also very, very relevant for us. So finally, just to say, HERT is interested, as you, Sebastian, said before, to deliver impact. So we don't like to deliver only paper. We want to deliver impact, we want to deliver real results, and for that we need the strong collaboration with Innovation Pillar and Flagship. Thank you.
Thank you, Emilia. In Emilia and Torben's presentation, we have talked about the topic of data availability, but this data does not only need to be available and collected by the different systems, but also centralized. So my question to Jerzy is, why is it essential to centralize data to improve the asset management in the railway environment?
Thank you very much. Well, first of all, we need to understand that data centralization is generally, it is what it sounds like. It's getting all the company data in one place, considering assets and processes. Those data should be stored in raw, in processed, and in the context of metadata. Having data in one place gives you some important advantages, meaning logically one place. You have a so-called single point of truth. That is, there is one place where the information is coming from, and there are no disparity in what kind of content is provided to different places of organization. As Torben mentioned, the problem is siloing. The situation when departments or company parts are storing their data separately and there's no synchronization. And in worst case, they are collecting the same data individually because they don't know what is accessible really. And this is not really a new concept in a business world where traditionally ERP system, enterprise resource planning system like SAP, were storing that data and considering them on a business case. However, when we move to the railway world, the difficulty ramps up to 10, where we have not only business data that are being handled by some systems, but also we have condition monitoring data, we have sensor data, we have TMSs, we have a lot of information that is coming to one place, and it's becoming more and more complicated to handle it. And those disparate sources can become very difficult to maintain. Providing centralization of data, we can increase the security of the data process, we can help the both strategical and tactical management through data decision support processes on multiple levels, improve quality of the data by monitoring, and generally increase efficiency in the organization of how data is being used, processed, and maintained.
So my next question would be, how does data centralization help in the asset management environment?
Well, traditionally, data asset management and decision supports in a business level were like relegated to business intelligence solutions. And this is not really any case anymore. Now we can support machine learning technologies. We can even use in more or less relevant ways so-called artificial intelligence. And such operational use can be focused on multiple levels of organization, on the front lines, when we can provide even low-level personal decision support information that helps them make their decision, even to strategical approach when we can plan changes in assets or extending them. Having the centralized data allows us to reduce the workload that comes with all kind of data processing that comes from, for example, individual processing and preparation of data in every place when they are being used. And traditionally, we know that data processing and data preparation for use takes like a 90% of entire time of doing that. So it reduces not only costs, but most importantly time that is needed to provide service. And you can do centralization in multiple ways, from databases through data lakes that we are actually partial to, or big data warehouses. However, all those things require appropriate solution of data accessing that can be later put into use in decision support. And you can, in more traditional approaches, you can base it on ETL or ELT. And ELT is something that's, I think, is most relevant for railway applications. That is, extract information, load information, and transform. So you store everything, and then you transform it to use in multiple systems that can be later, but because you store everything, you can access that later, and you can build new systems, because now we are seeing what kind of possibilities we have to create data decision support systems for railways, and having them supported with right data structure from the start will give us opportunities to develop more and more solutions and further digitalize asset management in the future.
Thank you very much. I would like now to talk about an important aspect of asset management, so artificial intelligence. We know it's a hot topic nowadays, but the implementation of artificial intelligence is also a gray area. So my question for Luca is, how do we address the problem of trust in AI, in prediction, especially in a difficult context like the railway environment?
One of the main problems of current generation of AI system is the fact that they search for correlation. And this is good when you need to make something work, but it's not so good when you apply these things in practice, because correlation doesn't mean causality. So it means that the model may predict something based on something that is completely nonsense. So finding a way to construct a causal model is for sure something important. We need explainability, so when we cannot do something that is that learns causality, maybe we can try to understand, inspect what the model is doing. We need to deal also with the fact that sometimes some data cannot be shared, so we need to learn from this data without sharing the information, so privacy preserving data analysis with federated learning or with cryptographic techniques. We need to deal with the robustness of this model, so the fact that there's perturbation in the data, which can be in some sense natural, so we have data that are not good quality, as explained by the other panelists before, or by malicious people that try to inject noise in the data such that to make some AI building illusions. But we can also improve the quality of the data with the use of current generation of large language models, which are the best way to basically clean and enrich bad data with high quality data. So there are multiple problems that born from the fact that current generation of AI is born for other purposes, and we are using it in a critical scenario, but we have a solution that we can deploy in order to make these tools more reliable in such a complex context like railway.
Thank you. Another problem is when we can trust prediction that comes from AI, how these predictions are then used and how we, let's say, manage the interaction between AI and the human. So can you walk us through the problem of the human in the loop in regulation?
Absolutely. One of the most important aspects of current generation of AI is the fact that people have understood that we cannot simply plug the system into practice without any human supervision. Human supervision means that, of course, this information can be leveraged by humans to take more, let's say, conscious decision, but also that humans have some particular skills, so information regarding a particular domain that can be infused inside AI in order to make more informed, more AI-based and domain-specific informed decision. Regulation will also push us toward a more, let's say, cautious way of using the system. The AI Act will have a deep impact in the future generation of AI-based system. Of course, the system that we are talking here are not the one that will prohibited. They are, in some cases, high-risk models of low-level risk models. So we will be able to continue to produce them, but we need to be sure that the fact that we will become accountable for the decision that this model takes as industry or as researcher or as AI deployer. And so we need to reason and put some filter. A human is okay, but in some situations humans cannot be used because they need to take so many decisions that we cannot use humans in the loop. And so we need to find the best trade-off between managing to help a human in taking decision, but also building a more informed and trustworthy AI system that can be deployed alone in practice.
Thank you. Okay, now we have talked during the panel about data availability, the importance of the quality of data, and how, based on this data, we can provide analytics and implement artificial intelligence to make prediction. All of this information together can support the operator and, let's say, be integrated in a decision support system. So my question for you, Daniela, is maybe to take a step back and to discuss what is the current application of DSS in the railway environment.
Yeah, thank you. You know, we are living this phase of the evolution of the control center, since we are moving from an actual situation where operators spend a significant amount of time watching screen and taking decisions on the basis of their own experience and knowledge, to a final and ideal solution in which the system would be able, thanks to an ever-increasing level of automation and machine learning, artificial intelligence technique, to manage complex procedures and letting the operators only to take final decisions. Of course, the road of evolution has to follow a step-by-step approach, and within this, a first intermediate but really important step can be achieved by the introduction of decision support system. I'm involved in the FP3-IAM4Rail context in the flagship project number 1 in Motional, and within this, in particular within the WP 13 and 14, we are developing a DSS that whose scope is basically to help the operators in the management of procedures when problem along the line occurs. The main features of this system are, for example, to provide the right notification to the right operators in the control center when a problem occurs, with all the relevant information needed to the operator to understand which is the problem, and address the related procedure, as I said, to the correct operator according to their role and managed territory. Moreover, through the DSS, the operator can access to the procedure detail, that is basically the list of tasks that the operator has to perform. But this is not to be intended as a static list of things that the operators has to check and perform, but this is something that is dynamic, because the system asks to the operator to enter some information, and on the basis of the outcome of the previous task, this list is updated. Also, the system provides some specific detail page where the operators can consult the information about the task, or, for example, specific pop-up to perform actions such as providing call, all scheduling maintenance activities. Another important aspect is about the management of multiple procedures. So if more than one event occur at the same time, the system provide the possibility to the operator to switch among different open procedures, or even to provide priorities among this alarm. So all of this to say that this is basically the scope of the DSS, a first version of prototype of a DSS that we are developing, whose scope is to reduce the workload of the operators to optimize the management of the line, and by reducing, of course, the risk of human error.
In this interaction, the DSS and the IAMS and Intelligent Asset Management System can interact together, as I said, to maybe exchange information about asset status, prediction, etc. You mentioned also the work that you are doing in FP1. So the final question would be, how can we use this information about the status of the asset to support the operators and the maintainers?
Another important aspect is that the DSS can be set, can be configured to manage a subset of events in general that are chosen a priori. This event could be alarm related to actual disruption that occurs, but even, for example, frequent time spending nominal procedure, or also the management of anomalies detected by the Intelligent Asset Management System about specific asset along the line. We showed during InnoTrans in Berlin during the last week of September how the DSS works in a specific scenario that is related to this last possibility. In particular, the scenario was about the IAMS detecting a possible malfunctioning of a track circuit, and sending this information as a warning to the DSS. So the DSS asked the operators to perform some first initial check operation to understand if this warning is symptomatic of a real malfunctioning, and if so, the system helps suggest the operator to schedule a maintenance intervention, providing some possible time slot in which the maintenance intervention can be scheduled on the basis of different information, such as the average duration of the maintenance intervention related to the warning received, the personnel needed from the maintenance crew, their availability, and of course the availability of the section of the line the asset is located. And then also at the scheduled time, the system provides a notification to the operators in the control center, but also to the operators that goes to the field, that they had their own tablet through which they follow the instructions suggested by the system. And also from the tablet, the operators from the field are asked to enter some useful information that are sent back from the DSS to IAMS, that use this information to store them and to feed also the algorithm that better predict this possible failure about this asset, and also the procedures associated to. So this is basically how these two words can be connected together.
Okay, thank you very much. Well, this concludes our panel discussion about the topic of cost-effective asset management. I would like to open the floor to the audience if you have any question for the panelists about this topic.
So first of all, thank you very much for your insights. This may be a bit provocative, but I also talk a lot with equipment manufacturers. What is your opinion on who owns the data and why? Is it the company that builds the equipment, operates the equipment? Is it the infrastructure managers? What is your insight on that?
The easiest answer is it depends. because we have so many data streams that are completely different in their character than when we have, for example, economical data, which are necessary for appropriate data asset management. They are obviously a property of the company. However, when you try to do some technical diagnostics, usually through subsidiaries, then issues become much more difficult. In certain cases, you have data administrator, that is a separate company that holds all the data but doesn't own any part of it, and the split of information within the same system cannot necessarily be available to one decision maker to access everything. We, in Poland, for example, has an example that through our TMS, there is a data streams from multiple operators on our railway market, and each separate part of that data stream is owned by their own, the individual railway operators, and there is no one decision maker that can allow you to transfer that data in one way or another. So it's very depends on the legal structure of things, on logical structure of things. So it doesn't have any easy answer for that solution.
Okay, thank you. Thank you for the interesting discussion. I have one question related with the regulation of the artificial intelligence, because it's here, artificial intelligence is coming just to live with us, but the regulation not always has the same development of the technology. And in that case, I think the artificial intelligence is faster a lot taking account the regulation. And I would like to know if it's part of the discussion, also in the development of the technology, how to implement strategies to combine this regulation with the development of the technology. Is this part also of the discussion? Thank you.
Yes, there are many roundtables around Europe about a way to make some sort of standardization of the procedure to define what is, for example, high-stake critical AI application or not, and how you can check, for example, if your model is explainable or not. Okay, there are different also European projects that are trying to harmonize the different proposals for standardization. Okay, to build up a sort of ISO. Okay, for saying what is explainable, what is correlation, what is causality, what is privacy preserving, and so on and so forth. We are for sure at the beginning, okay, in the sense that there is a lot of effort from at least 15 years, okay, in this direction. But the problem is that it's not easy to define this concept as we were used to when we were dealing with material things, okay? And of course, the fact that AI is going so fast with respect to what we are able to understand that is doing, okay, complicates the situation. Okay, this is why, for example, the AI Act is not technology dependent, but is application dependent. So basically it regulates the product based on their potential impact, not how they built the software inside. So even I don't know, something that is completely deterministic may be subject to the AI Act, even if there is no actually AI behind. Okay. So it's a risk-based approach like for medicine.
Yeah, thanks for the discussion. I have a specific question on data centralization, which Jerzy, you mentioned, and which is there also on that slide. My question is to the panel, how far do you want to take this concept in your thinking? Yeah? So you elaborated on data centralization within company borders, which somehow sounds reasonable, but I think we also have to reflect on the strategic value of data across the supply chain, and also to make things implementable. Yeah, when we think of bringing data somehow across different partners, which might give a favor also to decentralized approaches, which they're out there. So, question: decentralized or data centralization, where do you draw the borders, and how does this interact with maybe decentralized approaches?
Well, that's a loaded question, but what we were trying to understand when we are doing some planning, it was to create centralization on a logically handleable level. So, for example, for operation regarding transport operations, which we were doing in FP1, we were focusing on a municipality regional levels and then provide interfaces between possible centralized options. Generally, when we look on the aspect of asset management, organizational level seems to be adequate because all the decision chain is within one organization. However, providing interfaces for cooperation between multiple partners becomes an aspect which should be a next step when we can kind of standardize a way how to implement centralization in railway business. Then we can think how they can interface between one another, because obviously each company has its own specifics. There are situations when you have one operator that handles everything from rolling stock to station buildings, and on opposite in Poland we have complete company decentralization when our one large operator was divided into 26 companies, and that provides additional difficulties in case of exchanging information. But centralization provides a lot of value that really needs to be considered in order to make it some kind of workable and communicable between multiple partners later, but like have some kind of standard developed. And European projects are a great place to develop new standards, or at least concepts for future standards that will later be able to be proliferated in Europe and then provide necessary interfaces when they are really needed for some kind of strategical, bilateral or multilateral cooperations.
Are there... Yep.
I would like to add something. There are some proposals for dealing with these issues, so the fact that data are in different silos for different companies that actually deal with each other. So, for example, I am the owner of the infrastructure, but the data for maintenance are handled by someone else. It's called, let's say, data and model marketplace. So the idea to get the logical structure that has been explained by the other panelists, and then put some sort of notarized technology that help in keeping track of who is assessing what, and, for example, being able to enforce smart contract with regulation. So there is a proposal for this in a project that I was doing 3 years ago. It was Daydreams, okay, that tried to put this for maintenance on railway, okay. And the proposal was interesting because it is a way to not just find a solution that is, let's say, technologically sustainable, okay, but is also, let's say, legally sustainable. The fact that I share my company data with someone else, and in the future this guy can reuse this data for purposes that has not been, let's say, make clear at the beginning, can be handled both legally and also technologically. Okay.
Broken, you have a question? Because we are right on the minute. So if you want, I don't know, where is the microphone?
Thank you. I'm going to be very short, and I hope that the answer is also brief. This question goes to Daniela, because we are talking about the integration of assets information with TMS, and we were thinking immediately about command and signaling subsystem assets. But, well, we are having an extended application, of course, on more assets on that subsystem. But what I would like to know is what's your opinion about priorities in the other subsystems to be integrated with TMS?
Yeah, you know, what I mean for decision support system is something that is integrating more than one technologies. We are now in this context, and also the context of InnoTrans, focusing on YAMS, but of course the scenario are we can cover with this kind of application are very wide, and of course depends on which are the context in which the user is interested in. So basically, I think that the dialogue with the infrastructure manager and the final user, that is the operator from the control centers, could be the answer. So on the basis of which is the priority of the user, the DSS can be set to manage the different type of procedures that are related to.
Thank you.
Thank you. So this concludes the panel discussion 1. We are available, of course, during the lunch break for any question if you want, and also for the demonstrator. I would like to thank all the panelists for being here, and thank you very much for listening.